There are but 11 functional groups that you need to know to survive IB chemistry. Uh, Intentionally, I go slow, and I also have numbered them so you have easy time to review. It's a good time to prepare index cards in order to memorize the nomenclature because soon we walk into the reactions. I go after a category collectively known as hydrocarbons. They only have carbon and hydrogen in them, and they're broken into three families. One is alkane, which is saturated. They only have single carbon to carbon bonds. Their ending is ane, and their generic or general formula is RH. Just a note, R could be hydrogen, or it could be any other group, any other part of organic compound. So, for example, you could have CH3, and this is methyl. You could have C2H5 attachment, which is ethyl, and so forth and so on. So R is really a generic term or a variable used like X and Y. It could represent hydrogen or carbon member. It's any other part of the alkane. As example of a couple of alkanes, I give you methane, which you already have seen. It's one carbon, so it's CH4. You could have ethane, C2H6, so forth and so on. And if you elaborate on it, if you open ethane, for example, carbon to carbon single bond, and then you see it's occupied with hydrogens, 3 hydrogens on each carbon, it is known as saturated because you don't have any other room to add hydrogen to it. The carbon to carbon is single bond. The second group of hydrocarbons end in alkene, and they are unsaturated, and they have a double bond present in them. The last name changes into -ene. They still have the same generic formula RH. So I'll give you a couple of examples. For example, you could have ethene, which is C2H4. Now, if you open this structure, there is a double bond in existence, and then each carbon has only 2 hydrogens. It is known as unsaturated because now you have presence of double bond, and so forth and so on. You could have propene, butene. The next group is alkyne. It ends in -ine, and you can guess now you have triple bond. It's also unsaturated. As example, you could have ethyne, which is almost the most important alkyne, and it's C2H2. Now this time you have a presence of triple bond and single bond attachments to hydrogen. So this is ethyne. You could form other compounds of alkyne. So these are collectively as the first 3 functional groups under category of hydrocarbons. Now let's get into exciting parts. This is a good time to prepare your index cards. There is a group of alcohol. The ending in the name is ol, and the generic or general formula is ROH. For example, you could have methanol. It only has 1 carbon, and it's CH3OH. You could have ethanol, which is sugar alcohol, and it's C2H5OH. So the hydroxyl is the functional group. It's present in them, and C2H5 in this case is R, CH3 in the other case is also your R. So these are your alcohol. Then you could have amines. Amines end in amine, and it has a NH2 as your functional group. So you could have methyl amine as example, and it's CH3NH2. There is a lone pair of electron for nitrogen. I'm going to show it here. You could have ethylamine, C2H5NH2. The hydrogens could also be substituted with other alkyl groups. We get into more of specific nomenclature of amines later on in other slides, but this is amine. So if you have NH2, then you have presence of amine. Now there is something known as nitrile, and it also has a nitrogen, but you have to be careful with it. It ends always in carbon attached to nitrogen, a cyanide or cyano functional group. For example, you could have CH3, CN, and this, since it has two carbon, you're going to call it as that, as ethane nitrile. Now I'm going to open this to say there is a triple bond here between carbon and nitrogen. So this picture is CH3 attached single bond to carbon, then you have triple bond to nitrogen and a lone pair of electron. So this is a group that represents nitrile family. Another example I give you now, what if you have C2H5CN? Then since you have three carbons, spell it as that, propane nitrile. And if you open this, there's a CH3 here, CH2 here. Then you have single bond, triple bond to nitrogen, lone pair of electron. So this is nitrile. So I put them into 4, 5, 6 functional group. Now let's look at the remaining functional groups. And I categorically put them together. We'll see why. So we have aldehyde, which ends in al, ketone, which ends in on, carboxylic acid, which the last name will have oic acid in it, ester, which is combination of alcohol and carboxylic acid. Therefore, it's first name of the alcohol, last name of the carboxylic acid, and it has a il and OH. You'll see an example. And finally, you have amide, which is a combination of a carboxylic acid and amine group. Now, why did I do that? So aldehydes, they have this generic formula. They have R, C double bond O. I will end it in a few seconds. This C double bond O is known as carbonyl group. Ketones also have R, C double bond O. I leave it blank for a second, then I come back to it. Carboxylic acid, you will see they will have the same sort of going, a carbonyl group. Esters have double bond O, and then amines have double bond O. So they have something in similarity, and you have to be careful with that similarity as well. If you're aldehyde, the ending should end in H. For example, you could have formaldehyde, and it's HCOH. This is formaldehyde, but the IUPAC or the name that you should call it is one carbon, so this is methanal. Now, for a ketone to be true, the ending should not be hydrogen. It rather should be another R, or sometimes we write it as R prime. So this is a ketone. For example, the most important ketone is your acetone, which the name that you should give is propanone. So it's a CH3 attached to a carbon, double bond oxygen. Now make sure you end with another R group if you want a ketone. Since you have 1, 2, 3 carbon, you can call this propanone. And commercially, you have it as acetone, a great solvent. Then you have carboxylic acid, R, C double bond O. This time you end in a OH. So in order for you to be an organic acid, you should be RCOOH. Example of that, I give you ethanoic acid, which is your acetic acid. So if I have CH3, C double bond O, end in OH, this is ethanoic acid, because you have 2 carbon, eth for that. Now if you have an ester, which is combination of an alcohol and carboxylic acid, it should ends in OR 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 prime. It shouldn't be hydrogen. So for example, you could have CH3, C double bond O, OC CH3. Now this part is your alcohol, which is a methyl, and this part is your carboxylic acid, which was ethanoic acid. So this is methyl ethanoate. We get into their names a little bit more, and you need more practice on this. But it's great byproduct of organic chemistry that you need to know. Then finally we have amides, which if you're a bio major, you have seen it as amino acids. It will end, rather than anything else, a nitrogen family with two other attachments. It could be two other R's or it could be two other hydrogens. So this is what amide is. For example, you could have CH3, C double bond O, then end it in NH2. So this is example of amide.